In this lesson, we are going to go over solving quadratic inequalities. So in the previous lesson, we talked about what the graph of a quadratic equation could look like, what it means when we're solving these inequalities. And so today, in this lesson, we are going to go over the math behind solving quadratic inequalities. Okay, so our goal is to apply our understanding of quadratic inequalities to be able to solve quadratic inequalities. Okay, so there's some steps here that you can follow when you're solving quadratic inequalities. We want to make sure one side is equal to 0, and that's because we're able to find the zeros or the solutions. And if you remember from our introduction that these graphs are changing from negative to positive or positive to negative when at the zeros or when the equation is equal to 0. What we'll do is we'll make a sign chart and then we'll test points in our interval. Again, these zeros are breaking up the graph from negative, positive, negative, positive, negative, positive, and so on. We'll determine the intervals that make the inequality true. Okay, so whether we're looking for values of x that make it less than 0, greater than 0, less than or equal to 0, greater than or equal to 0, and then we'll make sure that we write our answer in interval notation. So let's get started with example 1. Solve the inequality. So we have x squared minus 2x minus 3, and we want to know when it's less than or equal to 0. So our goal here is to find the interval of x values. Remember, when we solve inequalities, we don't just usually end up with one solution, but many solutions, okay? So we want to know all of the x values that when we plug it into this quadratic, that it's 0 or smaller than 0. Okay, so the way we're going to do that is first, find the zeros of the equation because we already have one side, the right side is equal to 0. So we would be finding x squared minus 2x minus 3 and finding where that is equal to 0. We try factoring two numbers that multiply to negative 3 and add to negative 2. So we have x minus 3, x plus 1 is equal to 0. Okay, so from here we would get x is 3 and x is negative 1. So these are the two values that we're going to look at. Our graph could be doing a couple of different things. Okay, it could be like this, or it could be like this. So we're going to make our sign chart and test the values. So I'm going to rewrite the quadratic equation up here because I'll go over a couple of different ways. And remember, when it's in factored form, it's the same. It's equal to x squared minus 2x minus 3. So here's how I make my sign chart. I draw a number line. We found that our zeros were negative 1 and 3, okay? And we're also looking at where this is less than or equal to 0. So if these endpoints are included, or if these endpoints show up in our answer, they would be included. So they would get filled in circles, okay? So now I have 3 intervals that I need to test. This first one is negative infinity to negative 1, bracket, because the endpoints are included, negative 1 to 3, and 3 to infinity. Okay, now because of what these graphs look like, it's sufficient for our first interval to test any x value in this interval. So you could pick negative 1,000, negative 100, or negative 2 and keep it easy on yourself. So what we're going to do is we're going to substitute in negative 2 for x into our x squared minus 2x minus 3, and we're going to see if that's positive or negative. Again, the reason we're dealing with positive or negative is because these inequalities are dealing with greater than 0, less than 0, or something or equal to in there. So I'm going to check x as negative 2, and we'll talk about different ways you can check these throughout this problem. So we substitute it into the original, make sure negative 2 is squared, which means negative 2 times negative 2, minus 2 times negative 2 minus 3. So this is 4 plus 4 minus 3, 8 minus 3, which is 5. So this is positive. So everywhere in this interval, from negative 1 to negative infinity to negative 1, any x value in that interval that you substitute into the quadratic, you're going to get a positive value, okay? It's like this, x equals negative 2 was the representative of this interval, okay? In our interval negative 1 to 3, I'm going to check x equals 0. I try to pick easier numbers, and for this one I'm going to plug it into the factored form. Okay, this is just giving you different options. You can still plug it in to x squared minus 2x minus 3. So if I plug it in, 3, I'm going to get negative 3 times 1, which is negative 3, so this is a negative. So any x value, negative 1 to 3 would be, if you plug in negative 1, you'd get 0. We talked about that. But anything in between, you would be getting a negative. Okay? And then the last way that you can check these is I'm going to check x is 4 What you can kind of do is some mental math. 4 minus 3 is a positive, 4 plus 1 is a positive, positive times a positive is a positive. Okay, so if we plug it into our first factor, we'll get a positive, and we multiply it by our second factor. Positive times a positive is equal to a positive. Okay, so now that we've tested each interval, it's time to determine our intervals that make the inequality true. Remember, we wanted to know where this x squared minus 2x minus 3 is less than or equal to 0. Less than 0 is negative or equal to includes the endpoint, so we are looking at this one right here. So our final answer would be negative 1. That should have been a comma, but I guess they combined it with a 3. So our answer, negative 1 to 3. And again, the negative 1 and the 3 are included because it could be or equal to 0. And we found that negative 1 and 3 are the zeros. Okay. So we'll move on to the next one. Solve the inequality x squared plus 5x is greater than 0. We already have one of the sides of the inequality, 0. So the next step is to find the zeros by setting our quadratic equal to 0. So you can use factoring, square root property, or quadratic, just depending on what you're given. In this case, our first rule of factoring is looking for a greatest common factor. So I'm going to take an x out of each. Okay, and then from here, I would get x is 0 and x is negative 5. So these are the two values that are going to break up my number line in a way, or where the graph is going to change from positive to negative or negative to positive. So this is what we're going to put on our sign chart. Okay, and again, we had x squared, or we can think of it this way. So we have 0 and negative 5 is what we found. So I'm going to put open circles here because we're not going to be including the endpoints. Okay, so I'm putting open circles there. And then personally, I like to look at my intervals right away because once my sign chart is completed, I can look and I get my intervals right away. So picture this like a number line. We've got negative infinity to negative 5 to 0, and then 0 to infinity. So now we test points in each interval. You pick a representative for each one to represent that interval, and then that'll tell you if the values are positive or negative. So in this first interval, I'm going to do negative 6. And again, you can plug it into the original, or you can plug it into the factored form, or you can take a look and say, okay, this is going to be a negative if I plug in negative 6. This is going to be a negative. Negative times a negative is a positive. Okay, but I'll plug that in. So negative 6 times negative 1 is positive 6. So we have positive values here. Pick another representative for your second interval. I'll choose negative 1. I tend to choose smaller values just because there's less mistakes with me personally. So we have negative 1 times negative 1 plus 5, negative 1 times 4, negative 4. So as the representative of that interval, those values will be negative there. Okay, and then I'm just going to pick x equals 1. So we'd have 1 times 1 plus 5, 1 times 6 is positive. Okay, remember we are looking for intervals where the x values, when you plug them into x squared plus 5x, make it greater than 0. So we're talking about positive values. Okay, when you have two intervals, you join them with a union sign. Okay. So our final answer would be parentheses negative infinity to negative 5, union 0 to infinity, and it has to be written this way. Your intervals have to be written smallest to greatest so that the answer is correct. That's just how math people have determined to write these intervals. Next part of this question, is negative 1 a solution to the inequality? There's a couple ways you can do this. The first is to plug it right in and see if it makes the inequality true. So we'd plug in negative 1 squared, put it in parentheses, so remember to square the negative 1, plus 5 times negative 1, and we want to know, we're checking if that's greater than 0. So we have 1 plus negative 5. We want to know if that's greater than 0. Negative 4 is not greater than 0, so the answer would be no. You can also look to see if negative 1 falls in either of the intervals that we saw were the solution, and the answer is no. Okay. The last example that we'll do, solve the inequality. So we've got x squared plus 20 less than 8x. So the first thing is to make sure one of our sides is 0. I always keep my x squared positive, so I am going to subtract 8x from both sides to have x squared minus 8x plus 20 is less than 0. Okay, so now I need to find the zeros to see where my graph is going to change. So here I would be looking for two numbers that multiply to 20 and add to -8. So we're looking for two negative numbers. So you could have -5, -4, doesn't add to -8. If we have -10, -2, that adds to -12. So if it doesn't factor, we use the quadratic formula. Okay. So A would be equal to 1, B is equal to -8, and C is equal to 20. And then we start to plug it in. So we have x is equal to negative minus a -8 plus or minus the square root of -8 squared minus 4 times a times c all over 2 times a. I'm going to erase these factors here so that I give myself a little more room. And then we continue to simplify. So we have x is equal to 8 plus or minus 8 squared is 64 minus 4 times 1 times 20 is 80 all over 2 times 1. Okay, so what I'm going to do on the next slide is I'm just going to do the 64 minus 80, and I'm going to simplify the 2 times 1. 64 minus 80 is -16. So I have x is equal to 8 plus or minus the square root of -16 over 2. Square root of -16. Remember, square root of a negative, I is going to be involved. So this is going to be 4i. Okay, so x is equal to 8 plus or minus 4i divided by 2. And when all of these are divisible by the same number, you can simplify. So this gives us x equals 4 plus or minus 2i. So our two solutions are x plus 2, or 4 plus 2i and 4 minus 2i. These are not real numbers. So what this is telling us is that this graph does not cross the x-axis. Okay, this quadratic does not. So it's either going to be fully contained above the x-axis, meaning all the values are positive, or below, meaning all the values are negative. So what that means for our sign chart is we just really have to test one value, because any x value you plug in is either going to make it all positive or all negative. Okay. So if we test, our interval then is -infinity to infinity. Let's just check x equals 0. And here's our original. So if we plug in 0, we get 0 squared minus 8 times 0 plus 20. So this is 0 plus 20. So these are always going to be positive. Okay, so that means that this one is our first option, where everything is above the x-axis for positive y values, or any x value you plug in will make your quadratic positive. Okay, we were trying to determine where this is less than 0. So in this case, since it's always positive, this has an answer of no solution. Okay, no solution. On the next one, it's the same inequality, but now we're trying to find where it's greater than 0. Okay, and we can use what we just learned, that this graph does not cross the x-axis. We just discovered that everything is positive. So where is this graph greater than 0? Always. And so all real numbers, or in interval notation, -infinity to infinity. So the smallest negative number, they keep going to the biggest positive number. Okay. All right, thank you for watching. If you have any questions, feel free to reach out to me.